All right, welcome back. So in this video, we're going to talk a little bit more about the types of blood cells in blood. So remember, we call them formed elements. So up here, you've got the formed elements. All right, so remember what I said from Handout 19A. We've got three major types of blood cells. Red blood cells are called erythrocytes. That's the fancy name for red blood cells. White blood cells are called leukocytes. And then they're split into two categories. They have little granules in their cytoplasm. So, or some of them do, so that we call those granular leukocytes. Those consist of neutrophils, eosinophils, and basophils. And then we have agranulocytes that have no little grains in their cytoplasm. And they are the T cells and the B cells. These T and B cells are called lymphocytes together. So T and B lymphocytes. And then our monocytes. Monocytes become our immune cell called a macrophage. I'm going to try and spell this out here. Forgive me, I'm using a mouse to write, so it's not going to be perfect. So a macrophage is an activated monocyte. So they're the same thing essentially. Before they're activated to kill off a pathogen, we call them a monocyte. And then once they're activated, they are called a macrophage. So if you look, this is just a diagram down below where it shows us our red blood cells, erythrocytes, the platelets, which are next here. Platelets are called thrombocytes. And then we have our 6 different types of white blood cells or leukocytes. Okay, pretty cool. So all of the blood cells put together are called hematocrit. And I don't want to spend a lot of time on this. I'm going to try and condense things down a little bit. But the thing about hematocrit is you've probably heard of this term anemia. Anemia is when you don't have enough red blood cells. Red blood cells are going to be the cells that are delivering oxygen to our body. So if you feel really fatigued, tired, pale, you may have anemia, which is not having enough red blood cells or erythrocytes. We can also have too many red blood cells, and that's called polycythemia. Polycythemia is having too many red blood cells. And remember, typically we should have around 55% of our blood containing cells. All right. So we should have 55%. So if we get below 55%, we are anemic. If we get above 55%, it says over 62%, then we have polycythemia. Polycythemia can be due to a bunch of different things. Dehydration can change our percentages of blood to water, blood to blood plasma, or cells to blood plasma. Tissue hypoxia, this is not getting enough oxygen. So if you live in an area that's near sea level, like let's say you live in Los Angeles, you have more oxygen in the air than someone in Colorado. So when you move up to Colorado to go to CMU, you may suffer from hypoxia. There's less oxygen here than there is down in Los Angeles. So until your body beefs up its red blood cell production, you may have some hypoxia. And then this is now banned by all major athletic competitions, but if you take blood out, store it, and then put it right back in before your athletic event, that's called blood doping. And this gives you an extra boost because you're getting a lot more red blood cells that can carry oxygen. So you're basically making yourself polycythemic, and this is why they test like in the Olympics and stuff for blood doping. Okay, so let's talk about how these cells are created. And that's going to be handout 19B. And so it says most blood cells need to be continually replaced. We are always replacing blood cells. All right, red blood cells last several months, and then they have to be recycled. White blood cells may only live a few hours or a few days. They find a pathogen, they kill it, they may die themselves. So we're constantly recreating blood cells. All right, so I just have die within hours or days. The process of creating new blood cells is called hematopoiesis. Hematopoiesis is that process of making new blood cells. In the embryo, it happens all over the place. It can happen in the yolk sac, the liver, the spleen, thymus, red bone marrow. But what we're really interested in the adult, we really only make blood in our red bone marrow. So the red bone marrow is where we're going to be creating most of our blood cells. There's an exception to this, but you won't worry about it until ANP2. So let's switch over and look at our handout. Okay, so here is handout 19B. And if you look at it, I've got some stuff written. Don't worry about that just yet. In fact, I'll cover it up so we can zoom in. But hematopoiesis is the process of creating blood cells. All right? And it all starts with stem cells in your bone marrow. These stem cells in your bone marrow are called pluripotent stem cells. Pluripotent stem cells are the cells that have not differentiated at all within your bone marrow. All right? So pluripotent stem cells can become whatever they want to be. Now, when our body signals that we need a certain type of blood cell, these pluripotent stem cells are going to divide. And they have two choices. They can become myeloid stem cells, or they can become lymphoid stem cells. So once they differentiate and become either myeloid or lymphoid stem cells, their fate has been sealed. All right. So now they can't just become anything. Now they're on a road to becoming something specific. Let's look at this myeloid stem cell line first. All right. So the myeloid stem cell line, if I zoom into these myeloid stem cells, all right, these myeloid stem cells make up most of the cells that are in our blood. So myeloid stem cells can differentiate into erythrocytes, thrombocytes, and then 4 of our 6 leukocytes of our white blood cells. So they can become eosinophils, they can become basophils, neutrophils, and then our monocytes that become macrophages. Now, there's some steps to this process. So if, let's say we are hypoxic and we need more red blood cells. So our pluripotent stem cells are going to get a signal that we need to make the erythrocytes. So the pluripotent stem cells will divide into myeloid stem cells. And then the myeloid stem cells are going to differentiate and become more specific. They'll become proerythroblasts that'll then differentiate into reticulocytes. And then the reticulocytes, they're basically immature red blood cells. They will then mature into red blood cells or erythrocytes. Same thing with platelets. So let's imagine we need to clot our blood. We need to make platelets or thrombocytes. The pluripotent stem cells are going to differentiate into myeloid. The myeloid will differentiate into these cells called megakaryoplasts. And then megakaryoplasts become megakaryocytes, which then what actually happens is a platelet's not a true cell, it's just fragments of cells. So this megakaryocyte will then break apart into a bunch of little pieces, and those little pieces are enveloped in plasma membrane that become our platelets. Now, if we need to make white blood cells or leukocytes, the pluripotent stem cells differentiate into myeloid, and then those myeloid stem cells can differentiate into eosinophils, basophils, neutrophils, or monocytes. All right. So you need to know this pathway. So make sure that you understand the pluripotent stem cells become myeloid, and then if we need to make erythroblasts, the myeloid stem cells become reticulocytes. All right. If we want to make thrombocytes, they become megakaryocytes. And then you don't really have to worry about these intermediary cells for the white blood cells. I just want you to realize that myeloid stem cells can then become eosinophils, basophils, neutrophils, and monocytes. Let's quickly look at the other pathway. So this pluripotent stem cell can also, if need be, differentiate into lymphoid stem cells. Now, these lymphoid stem cells are going to make our other two white blood cells. So they're either going to make T lymphoblasts that become T lymphocytes, or they become B lymphoblasts that become B lymphocytes. All right. Now, you might wonder, why do we have all of these different cells? Well, they all have different functions. So I'm going to go ahead with this handout and talk about the different functions of these cells. So erythrocytes, or red blood cells, are going to be transporting oxygen. That's why we have so many in our bloodstream. 99% of all the blood cells in your bloodstream are erythrocytes. It's because they're carrying oxygen. This is also why blood is red. Our platelets are going to be clotting blood. I've already mentioned that. And then the 6 different white blood cells have 6 different functions. So we'll cover this maybe very briefly in another video. But eosinophils are going to be combating parasites. So if you get a parasitic infection like malaria is caused by a parasite, you're going to produce more eosinophils to fight off that parasitic infection. Eosinophils are also linked to allergies and asthma because when we have an allergy attack, we may mistake that allergen as a parasite. And then if you mistake that as a parasite, then you produce a bunch of eosinophils that are going to cause that allergy. Our basophils, now they're really considered mast cells. I guess we have 2 different types of basophils now. We have our typical basophils and we have our mast cells. You won't really have to worry about this until ANP2, but basophils and mast cells are going to be involved in inflammation. So what they do is they trigger inflammation. So when you get an injury or when you get an infection, you may have redness, swelling, tenderness. You may not be able to use the injured area. And that's all due to mast cells and basophils. So these basophil cells cause that inflammation. They cause the redness, they cause the pain, they cause the swelling. And because of this, they are also related to allergies. So when we have an allergic reaction to something, we may trigger basophils to just go crazy and cause a bunch of inflammation that causes our allergy attack. If you have seasonal allergies, this is what's going on for you. You are triggering your basophils to produce a lot of inflammation. All right. Our next cell is the neutrophil. Neutrophils are pretty cool because they are the first responders. They are going to undergo phagocytosis and eat foreign invaders. I like to think of the neutrophils as the Marines. So they are the first to arrive. They're the first to attack a pathogen. So if you get a bacterial infection, for example, neutrophils are going to be responding to that infection first. What they do is they eat the bacteria, that's called phagocytosis, and they destroy the bacteria. Similarly are the monocytes. Monocytes, when they come in contact with a pathogen, they become activated and turn into macrophages. And macrophages are doing something similar to the neutrophils. They're more specific. They attack specific pathogens. They respond to inflammation. They can emigrate and move to the sites of infection. And then they also phagocytize the foreign invader. All right. So these macrophages are going to be also eating and attacking that foreign invader. Now, the other two, T lymphocytes and B lymphocytes, just to make this very simple, because when you go into your next class in A&P2, you're going to learn a lot of specifics about these two. When I say T lymphocyte cells, this is a group of cells. There's actually a bunch of these types of T lymphocytes. We have natural killer cells, cytotoxic T cells. We have T helper cells, T memory cells. So this is really a group of cells. All right. Now, these guys are going to be attackers and helpers of attackers. So T lymphocyte cells are going to be attacking a pathogen as well. All right. They really focus on viruses and tumor cells. B cells, on the other hand, B cells are going to be making our antibodies. All right. So I kind of have them grouped here where I say natural killer cells, viruses, tumors. That function is the function of the T cells. The B cells are going to make your antibodies. Okay. So let's say, for example, that you get infected with coronavirus. All right. The coronavirus is going to be attacked by the group of cells we call T lymphocytes. So they have some cells called cytotoxic T cells and helper T cells, natural killer cells that are going to attack that virus. All right. So you're attacking that virus with your T cells. And then the B cells are going to be recognizing that virus, and they are going to be building antibodies against that virus. So when you recover from having that virus, you're going to have a bunch of antibodies that will guard against that infection a second time. And that's how, in a nutshell, how your immune system works. All right, like I said, you'll learn a lot more about this in A&P2, but this is a good introduction to our different blood cells. All right, so that concludes handout 19B. All right, we'll move on to 19C next video. All right, take care.